Right. Okay. In this video, just an introduction into the problem. Now, in the last video, I gave you three conditions to check for the three limits: the type 1 limit, or the type 2 limit, or the type 3 limit. And these conditions mainly involved the CDF capital F. Now, in this video, I'm going to talk about alternative conditions. So the title of this video is as follows. Right, these are alternative conditions to check which of the three limits is attained. Now, before I introduce the conditions, let me write some notation. So let f of t be the derivative of the capital F of t. So this is the density, this is the CDF, and let a of t be equal to the inverse function of f at 1 minus 1 over t, and let b of t be t times f at a of t. So these are three notations that we need. So for condition 1, type 1, for type 1 limit to be attained, this condition must be satisfied. So the limit of is equal to 1. Right? So if this condition is satisfied, then the limit will be the Gumbel limit, or the type 1 limit, right? Condition 2, if W of f is equal to infinity and the limit of at times bt as t goes to infinity is alpha, which is a positive real number, then type 2 limit will be attained, or the Fresher limit will be attained. And finally, condition 3, if W of f is a finite number and the limit of this is alpha, a positive real number, then type 3 limit will be attained. Alright, so these three conditions are equivalent to the previous conditions I gave you. So these conditions, so let me write that down. These Right? These conditions are equivalent to the previous conditions, and once again only one of the conditions will ever be satisfied. So for example, if the first condition is satisfied, then neither of these two will be. If this condition is satisfied, then neither of these two will be, and so on. So right, okay. Right, now the next thing I'm going to do is I'm going to do 3 examples, the same 3 examples I did in the previous video, and show you how to check these 3 conditions. Right? Okay, so let's start with example 1. Example 1, you may recall, is this is example 1, right? So so the first thing we need to work out is the derivative. So little f of x. So little f of x is the derivative of the capital F of x, right? And this is going to be e of y. So it's obvious that the derivative of this is this. Now the next thing we need to find out is a of t. Now in order to determine a of t, remember a of t, should go back to the slide. A of t is given by this formula. So we need to find the inverse function of f at 1 minus 1 divided by t. So the way to do that is as follows. To set f of x equal to this, and then solve for x in terms of t. So this implies taking the log, you have minus x equal to minus log of t. So x is equal to log of t, which implies that a at t must be equal to log at t. Next thing we need to find is b of t. Remember, b of t is defined as t times f at at. Okay, so this is t times little f is e minus at, which is at is, we know, is minus log of t, right? And this is t times this guy is 1 divided by t, so b of t is simply 1. Now condition 1, you may recall, is to check the condition that the limit as t tends to infinity of must be 1 or not. Alright, so this is the limit as t goes to infinity of 1 divided by 1, which is clearly equal to 1. So hence condition 1 holds, right? So this is the same example as the previous example 1, but we have used a different condition which is equivalent to the previous condition I gave you, right? And the result is the same, right? Now let's move on to example 2. The same example 2 that we looked at previously in the previous video. Alright, so this is example 2. We know from the previous video that W of f for this example is infinity. Okay, the first thing you need to find is the density function, which is the derivative. Alright, the next thing we need to find is the a of t. Now, as I said before, to find a of t, you must start with this statement. Alright, so hence a of t is equal to t. And the next thing you must find is b of t. Now remember, b of t is equal to t times f at a of t. So this is going to be t times f is okay, so this is going to be t times 1 over t squared, which is 1 over t. So b of t is 1 over t. Let's check condition 1. Condition 1 is that the limit of this must be 1, right? So the limit of and this is 1 over x, and this need not be 1. Okay, so this implies that condition okay. Now condition 2, for condition 2 we are looking at, alright, W of f we know is already infinity, so it is satisfied. Now we need to look at the limit at as t goes to infinity of at times bt, which is the limit as t goes to infinity of at is t and bt is 1 over t. So this is 1, which is a positive number, of course. So hence condition 2 holds with alpha equal to 1. Alright, so this is the same example as in the previous video, but done using a different condition, which is the same as, which is equivalent to the conditions I gave you in the previous video. Right. Finally, in this video, I'm going to look at example 3, the same example 3 that we looked at in the previous video. So this is example 3. So we're going to set the example is that where the CD of x, f of x is equal to x for x between 0 and 1. We know from the previous video that w of f is 1. The density function is the derivative, which is 1. Now to find a of t, you need to start with this statement, right, which implies that x is equal to 1 minus 1 over t. Hence, a of t is equal to 1 minus 1 over t. Now b of t, as you know, is b of t is t times f at at. So this is t times 1, which is t. So b of t is t. Now let's check the 3 conditions, starting with condition 1. The condition 1 says that the limit that this must be 1. Let's see if it is 1. And this is equal to x, and it's clearly not equal to 1. So hence condition 1 fails to hold. Now let's look at condition 2. For condition 2 to be satisfied, w of f must be infinity, but in this example w of f is 1, which is clearly not equal to infinity. So hence condition 2 fails to hold. Now finally, let's look at condition 3. W of f must be a finite number, which it is in this case, so that is satisfied. And the limit of w of f, which is 1 minus at multiplied by bt, must be equal to alpha. Let's see if that is the case. So this is going to be the limit as t goes to infinity of 1 minus AT is this, and your BT is T, and clearly this is equal to 1, right? So hence hence condition 3 holds with alpha equal to 1. Alright, so in the 3 examples I did in this video and the 3 examples I did in the previous video, one of the 3 conditions is satisfied. But there are examples where none of the 3 conditions will be satisfied. So in the next video I will do one example. There are many actually, but I will do one example where none of the 3 conditions will be satisfied.